Okay, I'm going to take a look at the different Linux processes that are running, understand them, basic understanding of them, and also see how we can view the processes and then ultimately kill them or stop them. At the command prompt, I'm logged in as root, so I have full administrative privileges over the system. And one of the first commands we're going to use to take a look at a process is the ps command. If I just type ps, it shows that the current running processes for this user, which is root, is bash. We can see that right here. The PID is the process ID. Every process has an ID that's associated, so the processor or the system can reference it, and the PID number is what's used to either identify the process or kill the process. And then you see the actual command that is running in that process, which is bash. And then the command ps, which is what I just ran. The ps command right here. So, if I want to see a little bit more information, because some processes have a parent process. So I can type ps-f, and that will show me a more full description of my processes. So again, I have the bash command and the time that it's used to run in that short amount of time, the start time when it did start, and the parent process, and then the actual process ID. So this 1390 is a process ID. It's a child process for the parent process 1302, which we'll take a look at here in a couple seconds by running another command. And the default user that ran this is root. That's the user ID associated with this. And the TTY identifies the terminal that I'm running this on, which is the console terminal. So next command will show me an expanded or an extended option and show me all of the processes or running across all the different terminals. And that command is ps-ef. This shows me all the processes. So if I hit the shift page up key a few times and go all the way to the top, I'm holding the shift page up command to go up there. You can see that the very first process run by root is process ID number 1. There is no parent process for process ID number 1. It would be impossible. And the start time is the time that my system was booted. And you can see that the command is sbin/init, which is the init process loaded from the kernel, which we learned previously. Yes, it is, the grandfather of all processes. The next process is the K thread, the kernel thread, which does not have a parent process. And then from there, the kernel thread loads all the other processes. As you can see, the parent process is 2. So they all are loaded from there. So if the shift page down, I can see that every single one of those different processes is a child process to the kernel. Page down, we can see some more. Oh, here's a couple that are actually a child process to the init process. Paging through, we can see all the the network management process. Here are some more that are actually processes from the init process. And we can see the bash process here that we saw from the previous commands run on the console 1 has a parent process of 1302. So we can see 1302 is here, and that is the login for root process. So that's where it initiated from. So the bash, which is the born again shell, the command that I'm typing these commands, has a parent of 1302. 1302 has a parent of the init process, which is my login for root. So there's an example of the ps command, and we can see all of the information. Now, learning how to use the bash command line, we can use some of the tools that we learned on how to see some of the input on this. So we can use the ps-ef command, and we can pipe that to grep and look for the word bash. And we can see the actual bash command and us running the command grep looking for the word bash. So both of them are displayed there. Again, that command was ps space -ef space pipe space grep space bash to look for the word bash.
And the numbers will change each time a lot of the process numbers will change each time you log in. Right?
That's correct. These, as you can see, that if I run this command again, my grep-bash process, the parent is, of course, running from bash. You see that here? And then my process ID for that grep-bash process is 1429. So if I execute this command again, now the process is 1431. So it keeps incrementing with every new process that runs. That is correct. Another option to list even more information is by using the ps-l command, and that just gives you a long listing. Some additional information that you might need later on, which goes a little bit beyond the scope of our function right here. Now, the next command, or the most popular ones, are the A option and the X option. The A option, which will list all processes across all the terminals, and the X option, which is going to list the processes that do not run on a terminal. So we do the ps space AX command, and we can see all the different processes. And if I just take a look at the top 10 rows, or the top 10 processes, I can run the command ps space AX space pipe that to head to show just the first 11 processes. Now the actual first line shows me the titles of each one of these columns, so I'm using head showing me 11 lines so I can see the top 10 processes that are running here. So in these we can see that some of them are noted with an S or a capital S and little s, and those are different symbols that indicate whether it is a the process is indicates a high priority or a low priority process, and the different symbols shown are based on the type of status of that. So if we want to see what the status S and little s mean, we can use the man command for PS, and we should be able to see, if I page down, we can see those different process letters and what they mean. The S is some information such as the CPU usage from dead child processes, and here it is, the process state codes. So way down towards the bottom of the man page, we have S is the interruptible sleep, waiting for an event to complete, and the greater than or less than symbols, the high priority, and the little s is a session leader. So all of these different codes are difficult to remember what they are, so again we can just take a look at the man page and we can find them in there. Hit Q to quit out of the man page, and again that command that we typed was ps-ax. Pipe that and identify the top 11 lines or the top 10 processes. Now a really interesting way that Linux saves each one of these processes is it creates a directory or a folder for each one of these processes, and that is stored in the PROC directory. So if we just take a look at the directory listing of this /proc, so ls space /proc, we can see that all of the process IDs and names are listed in here. So there's a lot of different processes. And if we use the ps tree command for the process tree, so ps tree, actually let me clear a bit here, so ps tree, and again we only want to look at the top 20 lines because it's going to go on forever. We can see the different processes, the very first one being init, and then from there we have the network manager, the ACPID, we see all these different ones, the login, and then from login we have the bash, and from bash we have the head command, which I just executed, and the ps tree command, which I just executed, which is nice. So these directories are created inside of the process folder, or the process directory, or from the root of your system. And these, obviously, these two right here don't exist anymore because this command is done executing. So it's kind of an interesting way of looking at the processes and the child's processes that run from them. If we just did this command without the head, you can see that's a fairly long process tree. And again, there's my login bash ps tree command that I just ran. Alright, the next tool to use in order to look at the processes is the top command. So just by typing the word TOP at the command prompt, we will see the top processes running on the system. And in here we have some options. For the get a full listing of different commands that you can run, just press the H key on the keyboard and it will show you all the different commands or just keystrokes that you can hit in order to get more information. So if we take a look at some of these commands, we can type the question mark or the H key to get help. And that's right down here, we can see those. If we want to quit out of the top program, we can just hit the letter Q. If we want to write this configuration file, we hit the capital W. If we want to kill a specific process, we can type K and then it will prompt us for the process number. And we can use the F, capital F command to sort by fields. So let's try that. So if we press any key to continue now and press capital F, so I'm going to hold the shift key down, hit the F, and I want to sort by CPU usage, which right now you can see a star means that that's how it's actually sorted. So let's sort by the process ID, so by A. Sort by the letter A, which is the process ID. And then type any of the key to return. Hit enter, and now it's showing me based on the process ID the order, with the largest number first, smallest number last. So if we want to change that, we hit Shift F, and we hit I think letter B based on the parent process ID, and then hit enter, and now we can see that the parent process ID is listed in that order, and that's on the right hand side of your screen. We're going to do it based on memory. We hit F and we choose N down at the bottom middle, memory usage, and then hit enter. So now it's sort of based on memory. The one using the most memory is our network manager.
And that might be a good thing to know. If you have to kill someone or kill something. That's
Yep. You can do this. I mean, this only shows, obviously, the top processes because it can't show you all of them at once. But it does give you at the top a nice statistical information on the percent of CPU utilization and memory utilization. And if you have any zombie processes, meaning a child process that lost its parent, it's just kind of running out there and it doesn't have any, it's essentially acting like a zombie. So that's nice to see. So if I want to kill a process, I'm going to kill the sendmail process. We can see the sendmail process on mine is right here. That actual process ID is 1250. Its parent is, of course, init. We're not going to kill it because that would just shut our system down. So we're going to kill 1250. So we hit the letter K to kill, and 1250. We type that in, and it will kill the process signal with process level 15. Now the process level 15 means the sig term. The software termination signal is the most common signal used to kill a process. The one that will absolutely kill it just by stopping the task completely is number 9. So if we just leave it at default 15, hit enter, you saw sendmail just disappeared. So our sendmail process has been killed.
And that's just temporary, or that?
No, that is permanently. It killed sendmail. So if I wanted to kill it, if I have another process in here like cron D 1278, which is this one right here, I kill 1278, and I can choose number 9, which is the absolute kill signal, and that killed the cron D process. If I hit Q to quit, it quits out of the top program. And if I type man space top, I can actually see some switches that I can add to this. So if I page down, I can see that I can use some different switches in order to see the different processes. So you can use the -P to monitor the PID number if you knew the exact number. How fast or delay you want it to update. So all those options are there. Again, hit Q to get out of the man process, and it takes you back to the command prompt. Another way to kill a process is by using the command kill at the command line. So let's find the SSH process at the command line. The SSH process we'd find by typing ps space -ef, and that of course lists all of them, but we want to find the SSH process. So we're going to use the same command, but we're going to pipe it to grep and look for SSH. So here we can see obviously our command that we just typed, grep SSH, but here's our actual SSHD process, and the process ID is 1234. So if I wanted to kill that process, I could use the command kill space and then the level that I want to send the signal, the kill signal with, and the kill signal levels that are most common are number 1, 2, 3, 15, and 9. The kill number 1 was kind of just called the hang-up signal. It stops the process and then restarts it. So if I do a kill -1 space SSH, oops, I got to type in the number, 1, 2, 3, 4, it should have restarted it, and if it restarted it, it should have a new process ID, correct? So now if I do this command and grep the SSH, I can see that SSHD now has a new process ID because the -1 was a kill and restart. And notice it's in a higher number than when it was first started when my system booted up. So if I wanted to kill that SSHD process because somebody insecurely or somebody hacked in my system and was connected to SSHD, I wanted to completely kill that process, then I could use the kill all command or the absolute kill, and that is number 9. That will force the Linux kernel to stop executing that process completely. So if I do kill space -9 space and then the process ID, which is 1492, it will kill that process completely. So if I take a look for it using the ps-ef, pipe it to grep, and look for SSH, I don't see it. The only thing I see is my grep command that I just typed. So if we remember from the previous lessons, how do we start the SSH daemon? No, not // because that would be in my present working directory. Just /. Do you remember what folder it's in? etc init.d sshd and start. And there my process has started. So now if I look for it using my ps-ef command and grepping SSH, I can see that my process ID is now even greater, and it's running. Its parent process is 1, which is in it. Now if I have a parent process that's running that has a bunch of child processes, and I want to kill all the processes associated with it, I use the kill all command, and that will kill all of the child processes. So let's take a look if there's something here that's not going to hurt too much. ps-ef. Where do we have a parent process that we can kill that won't kill too many things? 1 and 2 are fairly big. Held and held runner. So held is 1121, and we see that 1121 is the parent process to 1122, which is the parent process to this one, 1151 and 1168. So we're going to kill the held process by typing the kill all command, and we're going to kill the 1121, and we'll see what happens. Kill all space -9 to actually terminate it, space 1121. And that is a parent process to 3 other processes. No process to kill. 1121. Is that not it?
It's all, whatever.
No process to kill. Let's see if we can find another one then. There's the ch root helper daemon. Let's try that one. This one right here. So the parent process is 1040. No process to kill. Oh, you know what? We can't use the process ID. We got to use the actual name of the process when we use this. So, okay, here we go. Kill all -9 H A-L, I think it would be D.
Yeah.
H-A-L-D, because it will kill H-A-L-D, H-A-L-D runner, H-A-L-D add-on. There we go. Let's look for those, and I don't see them, do you?
No.
Oh, there's the held add-on. It didn't kill that one.
The zombie thing, huh?
Must be a zombie
Or orphan.
or orphan process. 1151. So if we kill -9 1151. Now that process is killed.
So why didn't it take that process?
I don't know why you didn't take that one.
Maybe because it was a child of a child?
Or yeah, or respawn from something else that happened. Yep, definitely. There's several different reasons why we could have that.
Could it be because it was inside? It wasn't, all the other HALDs were on the outside, like HAL, and then HAL-runner, and then that one was /user/5exec/
Oh, it's possibly.
who's within.
Possibly the HALD was within the actual command.
Within the
Or-
name, so it didn't take it rid of.
Yep, it's very possible. Okay, so the next thing is to take a look at. Actually, I probably should restart my system, and then we'll take a look at running these processes in the background. So I'm going to do an init 6 to restart it since I killed some things that I probably shouldn't have.